Hello, welcome to the netCIRCUItlabs electric circuit theory board. Let's say you're new to this system and you want to do something basic like measure a resistance. If we click on one of the blocks, you can see you have a variety of components that you can place on the board. So let's just start off over here. We have a voltage source, 5 volts. So if we want to measure a resistance, we'll put the resistance down. Let's say it's a 1K resistor, and we'll put voltage onto that 1K resistor to ground. But let's put another resistor in series with it, just so that we're not just measuring directly to ground. And we'll put the ground component on there. I need to emphasize, when you place these components, you're actually placing real hardware components and connecting to them with real analog switch connections. So the way I'm going to measure this resistance, which is a 1K resistor, is to measure the voltage across the resistance and divide it by the current through that resistor. On this board, we do not have an ohm meter, so we expect students to use voltage and current to work out the resistance. So let's make the connections. We'll connect the 5 volts to the 1K. We'll connect the 1K to the other 1K. We'll connect the 1K to ground. We now have a current flowing through these two resistors to ground, and we want to measure the voltage across these two. But how do we measure the current? Okay, it would be helpful to have a current meter in series. So what I will do is I will place a current meter here from the menu, current meter, and now I will put it in series by just changing my connections from here, click, click. Okay, so now I have the 5 volts flowing through a current meter through the resistors in question to ground. Now, I want to measure the voltage across this resistor. So let me have a look at the voltage at this point. Now it's a blue terminal, so blue terminals have to be measured by channel B or channel D. And let's have a look at the voltage. So the voltage at the top of the resistor is the blue signal, this signal here. Let's move it. And its value is 4.65 volts. If you want to see it more easily, you can push DMM, and you can see it's 4.65 volts. Okay, let's take a note of that, 4.65. Now let's look at the voltage on the other side of the resistor, the red terminal, and connect to channel A. Okay, there's the red signal. Let's move the scope channel down to the same 0 point. And now we can compare the two. The red is lower than the blue, obviously, because we've had a voltage drop. And what is the value of the red? It is 2.43 volts. Let's look at that with the DMM. 2.43 volts. Okay, very good. Let's write that down, 2.43. 2.43. Now, the difference between 4.65 and 2.43 is the voltage across that resistor and the connection. So that is 2.22 volts. Now, we worked that out by hand, but if you have a look here, it's possible to turn channel B into the difference between A and B. This is convenient. So if I click on this switch, channel B becomes the difference between A and B. And because B is greater than A, it's a negative signal. So it gives us 2.22 volts, which is what we would expect, because 4.65 minus 2.43 is 2.22 volts. Okay, so we have 2.22 volts across the resistor and the connection. Remember, these connections are not 0 ohms. They have a finite amount of resistance, which is discussed in the first chapter of the lab manual. Okay, Now let's have a look at the current flowing through this component. To do that, we connect the current meter output to the purple terminal. Once again, the current meter is able to be connected to the blue or the purple terminal, and the purple signal in volts is the current in milliamps. So let's have a look at that. The purple signal, channel D, is 1.97 volts, which corresponds to 1.97 volts, which corresponds to 1.97 milliamps. Okay, so now we have 2.22 volts divided by 1.97 milliamps equals, get my calculator, 2.22 divided by 1.97 equals 1,127 ohms. Okay, 1,127 ohms. So the voltage through that component divided by the current tells us the total resistance of that component plus the connection. Now, if you've read lab number 1, you'll see that the connections are typically 110 to 120 ohms. So we would expect the sum of this resistor and that connection to be typically 1,120. And our measurements show that it's 1,127 ohms. That's very close to the expected values. Any differences will be attributed to the fact that this connection may vary, and it is not always exactly 110, 120, plus or minus a few percent. And these components also have a tolerance of a few percent as well. So that's the end of that simple example on how to measure the resistance using voltage and current measurements. Thank you.